still writing proofs, still triangle congruency, but we're going to have a flashback to these corresponding pieces. This, my friends, is a throwback to like 5.2, the beginning of the chapter. Elliot, please be quiet and face the front, or I'm going to move you up front right next to me. So suppose that, use your congruent statement here, zero in on that. Complete each statement. Now, you know, I usually preach about let's draw a picture and mark all this stuff. I'm not even going to draw the pictures today, people. We're living on the edge. I'm going to work right off that congruent statement. Match it up. X, Y is going to be congruent to what two letters in the other triangle? RS, piece of cake, right? We don't need the picture. Okay, angle Z is going to be congruent to angle T. All right, cruise it on. Measure of angle S is going to equal the measure of angle Y. So, I know, I have number 4 at the bottom. I'm going to scroll it. Remember, because this is the new piece that's coming into play today. These are what we call corresponding parts. When you match up the different letters and angles, corresponding parts. You're going to hear me say that a lot today. All right, this is just a throwback to some old school algebra. If A is congruent to B, and A is 2x plus 40, B is 3x minus 10, find x. Well, they're congruent, they are equal. So I'm just going to set these expressions equal to each other. Take a second, solve it. You get a nice full number answer. You should get 50. Good work, my friends. And of course, add your 10 over, we get 50. So you're going to see me come back to this slide here in a minute because we're going to talk about these corresponding parts again today. So I'm going to reference that. So notice, what are we doing? Use congruent triangles in proofs. Proofs, remember, it's all proofs today. So there's nothing for you to write or do anything yet. I got to scroll it down. It's not on the slide, so hold on. By definition, congruent triangles have corresponding parts. So, corresponding parts. That's why we started it off with this. Back to it. If you can prove the two triangles are congruent with one of our 5 shortcuts over here on the board, okay, then of course the corresponding parts are congruent as well. So we are going to use what is called CPCTC today. That is a mouthful, I know. And what does that stand for? That is what you need to write on your note sheet. Corresponding parts of congruent triangles are congruent. Soapbox. You know I get fired up on a proof day. And you can use the congruent symbol too if you're running out of space on the blank. So that is exactly what it was talking about in the warm-up problems where we found those corresponding parts because they gave you congruent triangles. So we're going to use that today. So let's take a look. We got 3 proofs in the notes. Probably should have done 4. I don't know. That probably would have been more fun. You got 4 proofs in the homework. Yeah, the looks on your face is priceless right now. You have 4 proofs on Monday's quiz. I know, fun news keeps going. 3 proofs on the chapter test. And I can't remember how many are on the final exam, but there's a couple on the final. All right, let's do it. Let's do it. C is the midpoint. Good vocab word. I believe that was on our vocab quiz. Now, yeah, I know there's more in there and I'm going to mark it, but humor me. I know, I ask every day. What does the midpoint do? Okay, yep. Midpoint of BD. There we go. We got it. Okay, let's continue on. AB, congruent to CE. Now, they didn't mark that. I'm going to mark it. Oh, gosh. Okay, more. I'm going to move underneath it because I can't fit it all. AB, perpendicular to BD. Okay, we'll mark something for that, or maybe you mark something for that. And then CE, perpendicular BD. Given was a lot in the given. So much in the given. Now, next thing I'm going to ask you, you know it, perpendicular makes what type of angles? Right. So I'm going to mark the right angles on this picture. So let's read it here. AB, perpendicular to BD. So here's the right angle in that bottom left corner. And then it also tells me CE, perpendicular to BD. So my first question for you before I get carried away, which of our shortcuts are we going to use to prove those two triangles are congruent? Now I hear HL, and I'm hard no on HL.
Side angle side.
Side angle side. Why can we not use HL? We don't have the hypotenuse. You don't have the side across the right angle. I know, we see right triangles and we want to say HL, but we got to look close for that H. Now, I need 3 pieces of congruency, of course, to prove my triangles are congruent. And that's the only one they gave me. I marked these guys from the midpoint. So that's the next thing I'm going to put in here. Segment BC congruent to segment CD. And I marked that because of the midpoint. Definition of midpoint. Now, remember, we need 3 total pieces of congruency. I've got 2. Clearly, I need these angles. Well, I put the right angle symbols on those, so I first need to say they're right angles. I'm going to say angle B. Now, unfortunately, I can't just say angle C, because C is the vertex on multiple angles. I'm going to use the 3-letter name. I'm going to call it ECD. ECD are right. Okay, what in the given prompted me to put those right angles on? Definition of perpendicular. And you can use this symbol or abbreviate like I am, whatever you want to do there. Now remember, 3 pieces of congruency. I still only have just 2. But wait a minute, if they're right angles, aren't they congruent? Yeah. So angle B is congruent to angle ECD. What's our reason? What theorem? RACT. Right angle congruency theorem. All right angles are congruent. Okay, so, and clearly I'm out of room. I'm going to scroll it here in a second. But before I do that, because I'm going to scroll the picture maybe off just a smidge, am I ready to say they're congruent by side angle side? Do I have my 3 pieces of congruency? I sure do. So let me just move it so I can put my line 5 on here. Now I'm going to call the top triangle, I scrolled the A off, but it's at the top. I'm going to call the left one ABC, triangle ABC. Now you might have scrambled that in a different order, which is fine, but we have to keep the corresponding pieces together. I started at the top, I went ABC. So what do I need to use for the right triangle? ECD. And that was our side angle side. And just when you think you're done, is that the proof line? No. No. Okay, here it comes, my friends. Well, if the triangles are congruent, aren't the parts congruent? So I'm looking at this, I'm like AC, oh, ED, just like our warm-up problems, are corresponding parts. So once I have the triangles are congruent, here's the new part for today. We're going to say, of course, our proof line, ED. Of course, we're going to abbreviate our reason on that. Corresponding parts of congruent triangles are congruent. CPCTC. Say that 5 times fast. Yes, isn't that great? I love it. Only 2 proofs left to write in the notes. I'm a little sad. Little sad, kids. A little sad. All right, flip the page. Let's go again. Here we go. Here we go. Okay, GK. Bisects. Ooh, good word. Good word, bisects. Be thinking about what bisects means as you're writing this. Elliot, you're in the front.
I didn't even say anything.
You're turning around talking.
Actually turn to the side.
Front. Made poor Sadie move last time. All right, keyword, right in front in the action. It's going to be great, Elliot. Keyword bisect. What is bisect, Dave?
Cut in half.
Cut in half. Okay, now that GK, which is the middle, bisects 2 different angles. So we're going to be careful how we mark these. The first one it says that bisects is FGH. So it's cutting this big angle in half. So these 2 angles are congruent. I'm going to have to put that in the proof here in a minute, obviously. Also, angle FKH. So this big angle on the left side. So these 2 halves are congruent. So again, before I get any further carried away here, let's figure out which of the shortcuts we're going to use to prove the triangles are congruent. Now I like to have this shared side. Angle side angle is going to be our shortcut. Now here's the fun part, people. Do I have any congruent pieces yet in this proof?
No.
Cute, no? Okay, so we need to write a lot of stuff here. We got to do all three. I put the purple marks on first. I'm going to start with that. Now I can't just say angle G is congruent to G. We got to get specific and use our three letters. I'm going to call it FGK. Is congruent. I'm going to call the bottom one HGK. Now, I also put the blue marks on because of the same reason. What word and the given made me put the blue marks on also? Bisect. So we can use the same line here. I'm going to call the top one FKG. And I'll call the bottom angle HKG. Oh man. Well, yeah, we're going to go with that. Okay, bisect was the reason, so definition of bisect. And I do have kids that will split that up and make it lines 2 and 3. They'll do them separate and put def and bisect twice. You can, that's really fine. But if it's the same reason, you can do it all in one line. Now I also put the green mark on. I need that in here because I only have 2 pieces of congruency. So that's that shared side. So we're going to say KG congruent to KG. That's an easy reason. What's the reason for that? Reflexive. Remember, reflexive is a pretty common in these triangle proofs. Got it? Okay, so I think we've got our 3 pieces of congruency. We are ready to say they're congruent by angle side angle. Let's do it. Now I gotta be careful how I name these, okay? Order. You know me, I'm gonna start, here's how I'm gonna do it. I'm gonna start with the no congruent, I'm gonna go single double. So I'm gonna call this triangle HGK. You may have done a different order. I'm just going to keep the corresponding pieces together. Now, if I called the bottom one HGK, what are you starting with on the top triangle?
F.
F. So F, G, K. And we already figured out angle side angle over there. And then take a little look-see. Is that the proved line? No, but hey, we just have one extra piece to do. So they have FK, so the outside two, yep. HK, oh yeah, corresponding parts. We have corresponding parts are congruent, yeah, for sure. All right, corresponding parts of congruent triangles are congruent. Let's abbreviate it. CPCTC. Piece of cake. That wasn't so bad. Any questions on that one? It's like a foreign language geometry. All right, let's do this last one. And of course, they didn't give me the little grid. Oh, I already feel like I'm going to run out of room here. All right, angle A is congruent to D. So it looks like they marked that, which is nice. I'm just, for dramatic emphasis, going to remark them in red. And then they also tells us there's that word bisect again. Now, I do see they marked that for us. Humor me, what's bisect mean? You just told me. Cut in half, okay, we know. So it's telling you, of course, AD bisects EC, so cut in half. So they put these on, which I do agree with. But I don't have that listed in my proof. Those purple sides are congruent, so I am going to throw those in here quick. I don't like that they marked it. ED, congruent, and then BC, def of bisect. Then we'll get into the triangles and what shortcut and all that good stuff. Okay. All right, once we have all of that in, do you see some other congruent pieces in the picture? Vertical angles, a little back. Okay, so I'm going to list those. That will be my third piece of congruence. Let me get out of the way. What shortcut on the board are you using to prove these are congruent? Angle, angle, side. 2 angles and a side. The side's not in between them. Angle, angle, side. Okay, so let's get our backed angles on here. On the home stretch. Now again, I can't just say angle B is congruent to angle B. We have to be specific with the letters. I'm going to call the left one angle ABE. And then I'm going to call the right one DBC. Make sure B is in the middle. Because I still see some random things when we name those angles. Vertex always in the middle. You guys already told me that. All right, and then we have our three pieces of congruency. We already figured it's angle, angle, side, so let's name our triangles. Now again, I gotta keep the corresponding parts together. I'm gonna start with a no congruent, then I'm gonna go single, double. So I'm gonna call this left one EAB. Now if that's the order I'm gonna go with EAB, what do I have to call the right one?
DBC,
CDB. Because I went no congruent mark, single congruent, double. I had to do the same order. No congruent, single, double. All right, is that the proof line?
No.
Look at the proof lines. Okay, so we're still going, people, still going. We have, guess how many more steps? Are you ready?
8.
Not 8, not 8. Dos. My Spanish is really getting good. Okay, humor me, humor me. I am the prize. We're trying to get to midpoint. You know it. What does the midpoint do?
Cut in half.
Cut in half. So if I can show like two sides, the two halves are congruent, I can say it's a midpoint. Well, I think we can do that. So I want to show that E is the midpoint of segment AD. So I'm looking at these guys. If I can show those are congruent, I'm in business. And I think I can, because I have AB. Does that pair up to DB on the other triangle? Yeah. So I'm going to say, all right, AB is congruent to DB. Corresponding parts of congruent triangles are congruent. CPCTC. Now, if those two halves, those two sides are congruent, that's a midpoint. What's the reason? Definition of definition of midpoint. Midpoint, that's what a midpoint does. You have the two congruent halves. That was a good one. That was a good one. I liked it. Any questions on that? Okay, next, that was the last formal proof we're gonna do. Don't freak out on me. Don't give me a dirty look. This we just gotta kind of talk about. Identify which triangles are congruent. Well, let's start with that. In order to prove, of course, that statement. I'm not writing out a proof. We're not writing out a proof. We're first just gonna figure out why are these two triangles congruent. Which of the shortcuts would you use? Side, side, side. Because you have your shared side here. Okay, so we would be using side, side, side. So that's the first thing it asks. Then it asks, how would we prove that these are congruent? Well, I'm going to get fancy because you know I'm all about fancy. If I'm going to name these triangles, I'm going to make a triangle congruent statement. I'm going to start with L. L, M, O. And then the right one, I would call it, I'd start on the outside here, N, M, O. So my question to you is, you have corresponding parts. What is it? Corresponding parts of?
Congruent triangles are congruent.
That's so great. So great. I love it. Okay, ready for the SAT problem? Just when the fun never ends, kids. Okay, here we
I'm
go.
gonna break my arms.
This isn't that bad. Well, kind of, sort of, maybe. Again, trying to keep you out of having to take STP math next year. Let's remember the goal. Who was so wordy? If A is an odd integer, I hope you know what odd and integer means. B is an even integer. Which of the following is an odd? Now, I look at this and like your mind starts to gloss over with all the letters. Same advice I'm going to give you as it gets closer to PSAT. Test it. Pick some numbers and actually test these. So if A is an odd integer, give me a small, so I don't get my calculator out, small odd integer.
1.
B is an even integer. Give me a small even. So I'm just going to test these really quickly and calculate them and see which one turns out to be odd. Well, 3B. If I do 3 times 2, you get what?
5. No. 6.
The end of the day. Not it. If I put 1 in here, what's 1 plus 3?
4.
Not it. Lord, it's probably going to be E. If I do parentheses first, 1 plus 2 would be times 2 Not it. Okay, 1 plus 4. 5. I think that's gonna be the winner. 2 times 1 plus 2. That's even. It's gotta be D. Gotta be D. So you can always like make some numbers and kind of test it. That wasn't that bad, was it?